Bonjour, Genève. Hello, Geneva. So, I was told for this performance to do it in French because there's a lot of French speakers here. Donc, on m'a demandé de faire cette show en français, mais pour savoir quelle langue est le mieux, je vais essayer de vous demander, quand je dis Bonjour Genève, tout le monde qui souhaite que je parle en français crie le plus fort que possible. And when I say Hello Geneva, if you prefer for the show to be in English, applaud as loud as you can. Okay? Bonjour Genève. Hello Geneva. Désolé pour la francophonie, l'anglais est clairement le gagnant. So I'll stay in English. Sorry for anyone who doesn't follow things so well. So, it's a beautiful day in the park. It's a great time to relax and have a beer with a couple friends. But beer should be nice and cold, and we want to measure the temperature of that beer. Unfortunately, my thermometer is broken. I'm not joking. If anyone wants to check, this is a broken thermometer. A lot of you from the other stands recognize me from coming around saying, does anyone have a thermometer? Does anyone have a thermometer? I'm going on stage and I need a thermometer. That's okay. We'll just make our own. Believe it or not, we can use this bottle of beer to make a thermometer. However, the thermal expansion of air is over 1,000 times bigger than the thermal expansion of beer. Therefore, I'm going to need 1 or 2 volunteers to help me fill this bottle full of air. For this, I'm going to need an adult, ideally someone who likes beer. We have 1 volunteer there. Come on up. Do we have a second volunteer? Sure, second volunteer, come up on stage. So, before we start, you have a challenge. I'm going to ask you to take one of the pages of the Science Me program and use that to open the bottle of beer. Now, as they're trying this, it's worth pointing out that paper is quite strong for tensile strength. Doesn't rip apart easily that way, but it tears easily and is quite flexible. So if we use the tensile strength and fold it together a number of times, creasing it very well, and these are science communicators, so I think they'll have a pretty good shot at it. So just making a nice tight package. So of course, it's always good to have a backup plan in case it doesn't work. I also have a bottle opener here in case we needed it. But just to show that it can be done with a piece of paper, I've folded this one nice and tightly. And now it's ready to fill with air. Now, when we go to do this, we're going to see who can fill it with air the fastest. You can choose to drink it if you want, but feel free to use cups, straws, the bucket, anything you want. And on the count of 3, we're all going to try and fill our bottles with air as quickly as possible. Let's cheers together. Should we say skål or?
Yeah.
Okay. So 3, 2, 1, skål.
Skål.
In the name of science. So, thank you. You can sit back down now. Let's applaud them. Okay, so now we have these. This one is not full of air. Anyways, as you may have noticed, some of us were using straws. If you think about how water flows, I'm going to take these full bottles and empty them one by one into the bucket. And notice how liquid flows through a container. Kind of it goes glug, 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 glug. Because the air needs to get around the water to get through. What I was using with the tube there was just a way to bypass the water and the surface tension of the water and get the air straight into the bottle. So notice how much quicker this one will flow out now when we use a straw to help empty it. Now, getting back to the idea of the thermometer, I'm just going to turn on this kettle, which the table isn't plugged in. So hopefully we can plug in that kettle. Good thing I thought of it a moment before I needed it. Okay, so now the bottle's full of air. Air expands a lot when you heat it. So we can use this to make a thermometer. But can we see the air inside? No, air is invisible. So I'm going to use a balloon to trap the air inside. And my first attempt at a thermometer, I'm going to use this kettle, which hopefully is still hot from preheating it backstage. Oh yeah, that's hot. And I'm just going to put it in the kettle, and we should see we have a thermometer. What is it? Is that good enough? No, probably not. Like, we can see that it got hotter, but we can't put any numbers to this. So let's calibrate a thermometer with some numbers. We need to put the air in somewhere smaller, but air still isn't visible. So I'm going to use the balloon again, but I'm going to use the balloon in the other direction. And here I just have a regular Bic pen that ran out of ink. I threw the ink cartridge out and jammed it through a cork so it'll fit in the bottle. That, with the balloon and a little bit of colored water, should be just about enough to have a functional thermometer. So I'm going to put the balloon in the bottle, fill it with green colored water so we can see that. Hopefully not make too big of a mess. And ta-da, we have a thermometer. Now, to check that it works, we need a source of heat. So for this part, I need a couple more volunteers. But don't worry, you can stay where you're seated. Some of you can generate your own heat. So anyone who feels like making some heat, just take your hands, put them together, and rub. And I'm going to come around, and whoever thinks they have really hot hands, just when I come by, grab the bottle, and we should be able to see the temperature rising. The bottle. So we're heating the air in the bottle, and it pushes the balloon up. And I'm going to go from person to person, so collectively, with some different people's heat, we managed to get it all the way to the top, just with 2 volunteers. Let's give them a round of applause. Now we can see one of the 2 limitations of this thermometer. It can't measure very high temperatures. Just with human bodies, we got it past the top. And it doesn't have any numbers on it. So, I prepared ahead of time a longer version of the same thing, which I'll just recalibrate, reset to 0. Top it up with a little bit more green water so we're sure we have enough. And this is the part of the show where I was originally frustrated I didn't have a working thermometer, but I think it'll work out better without. So I'm going to use 2 fixed points. I'm first going to put it in this bucket of cold water. The water, like the beer, came out of the fridge. The fridge was about 4 degrees, but we've been on stage for about 6 minutes now. So by Newton's law of cooling, it should be exactly 10 degrees. And if it contracts too far, I'm just going to add a little bit more water so we can measure the lowest point. So we have our lowest fixed point down there. We're going to move it to the boiling water. And we should be able to see it rise all the way up, and hopefully it'll stop around here, which is about 1.20 meters. Go, 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 go. And so, now, who likes math? Everyone. Excellent, a lukewarm answer. So I'm going to skip the math behind this. And I'm just going to tell you that in this meter-long tube, meter 20 long tube, if we have 330 milliliters of air that can expand and cool, if we extrapolate that, and instead of warm, we cool it, we imagine what would happen if all of this air went to a volume of 0. We extrapolate that the other way around, and we get a value close to minus 300 degrees. Now, absolute zero, if you've heard of it, that's how it was first proposed. And we can get within 10% of that just by drinking a couple of beers in a park on a nice sunny day. So, with that calculation out of the way, it's time for me to grab another beer, come join you in the public to see some awesome science, and enjoy this wonderful festival. Thank you, Geneva.